Have you ever wondered, does the damping affect natural frequency in the modal analysis? Because theoretically it should, right? Let's start with a simple degree of freedom system, a mass and a spring. We know that the natural frequency of this system is 1 by 2 pi root over k by m. And in this we assume like there is no damping involved. So we are neglecting the c term here in our equation of motion. But if we include damping, this damping will be this damped natural frequency will be going to be 1 root over 1 minus zeta square into our natural frequency. So where zeta will be nothing but the damping ratio, and the damping ratio is always positive. So suppose any frequency, so suppose uh, any frequency, if I got suppose 50 hertz as a natural frequency, automatically my damped natural frequency, if suppose zeta is suppose zeta is 5% damping, then my damped natural frequency is going to be 49.875, which is just below the 50. So ideally, my damped natural frequency is always going to be little less than my natural frequency. That's the thing we can understand from the spring mass system. So let's run this analysis without damping and with damping modal analysis in any solver and find out whether same thing is happening in the modal analysis or not. So if you see, the modal analysis solves for eigenvalue problem based on mass and stiffness matrix, and it neglects the damping. So there is no damping matrix involved here. So that's why it always neglects damping. So for a simple modal analysis, it doesn't consider damping, but it is an industry standard to evaluate the natural frequency of any system using this modal analysis only. There is one more modal analysis called as complex eigenvalue analysis, which includes C matrix, but it is not generally used. Why? Because if you see, if your natural frequency is 50 hertz, just now we have seen it. If we use suppose 5% of the damping rate of the damping ratio, we find out our natural frequency reduces from 50 hertz to 49.875 hertz. That is very negligible difference in the natural frequency. We always use the simple eigenvalue extraction, that is a standard modal analysis. Damping, whatever damping defined here can be used in modal FRF and modal transient analysis, which are somewhat advanced analysis and which we will discuss later in some other video. Whatever the standard modal analysis you run, it doesn't consider the damping effects in the natural frequency. So thank you. Have a great day.